Okay, you are getting ready for the first quiz in the Changes and Bonds 2 unit, and it is called Ionic and Covalent Bonding. So this file right here is an image, and there's a copy of it over on the wall. Probably wouldn't be a bad idea for you guys to go grab a copy of this paper right here and maybe jot some notes down on it as you watch this video. And I'll come back to this. So before I really get going, I want to do a little bit of review. I want to review orbitals and how they relate to the periodic table. So what's an orbital? An orbital, you may remember, is these shapes. Each one of these shapes is an orbital, and the orbitals are where the electrons go. So orbitals hold electrons. And each orbital can hold 2 electrons. So whichever one of these shapes you look at, they can hold 2 electrons. And that explains why, like if we look at this first spherical one right here, that explains why if we look at the periodic table, this block is 2 atoms wide because each little spherical orbital can hold 2 electrons. Or if we look at another one, let's look at these blue ones. There's 1, 2, 3, 4, 5 different types of these blue orbitals. We call them d orbitals. But since there's 5 different types, that explains why this chunk of the table is 10 atoms wide, because each orbital can hold 2 electrons. So why is that important? It's important because it makes group 18 special. It makes these guys special. Why are they special? They are special because their outer orbital is full. It's kind of like I think of like a jigsaw puzzle that's not missing any pieces. It's just kind of like it's nicer. Or like we talked in energy, we talked about how nature says if you have a boulder at the top of a hill, the universe would rather have that boulder at the bottom of the hill. These guys with their outer uh, orbitals full, they have less energy and they are more stable. So everybody else would kind of like to be like them. And this video is pretty much about how other atoms get to be like these uh, group 18 atoms. So let me clean this stuff up a little bit and I'll be right back. So we're going to get going here, and it's probably the best place to start is with ionic bonding. I think it's the easiest one to understand. So why would someone make an ionic bond? Well, let's talk about a couple of different elements. Let's talk about fluorine and what's this? This one's potassium right here. So fluorine has room for one more electron, so it wants 1 electron. If it gets that 1 electron, it becomes chemically like neon. It's much more stable. So fluorine would like to be like neon. Potassium has one outer electron, and rather than try and gain a whole boatload of electrons to be like this one, it seems a lot easier to lose 1 electron. So if potassium loses 1 electron, it becomes like this noble gas right here, argon. So what if you had a potassium atom and a fluorine atom meet? Let's draw a couple next to each other here. If they meet each other, what happens is an electron, an electron leaves potassium and goes to fluorine. So now we have a positive ion and a negative ion, because fluorine now has one extra negative and potassium has lost a negative. So that electrical attraction is what holds these guys together. And that attraction is pretty dang strong too. Like if you want to take table salt and melt it, you've got to get it dang hot, something like, I don't know, 800 degrees or something. These ionic substances, we call them salts. They are made with a metal and a nonmetal. It happens when electrons transfer, and it explains why you get, like if you ever look really close at table salt, you'll notice that it's always these little cubes. It's kind of sweet if you look closely at it. Anyway, that's ionic bonding. So what's next? What's next is covalent bonding. So if ionic bonding is a transfer, what is covalent bonding? Covalent bonding is when electrons are shared. So covalent is when electrons are shared. And who does that? Well, these nonmetals, these guys in this neighborhood right up here, these guys do covalent bonding. Why do they do that? Because these guys want more electrons, just like fluorine right here, or oxygen. These guys want more electrons. And if they meet other atoms that are also nonmetals, they can share them. So let's talk about fluorine again. So if I'm a fluorine atom and I want one more electron, and I'm another over here, there's another fluorine atom and it wants one more electron. If they meet, what they can do is they can overlap and they can share their outer electrons. And when they share, they both become stable. This is called a covalent bond. So in a covalent bond, that happens between a nonmetal and a nonmetal. It makes what we call molecules. And I know I have quiz questions about this. Remember, in an ionic bond, you have a positive and a negative ion. In a covalent bond, you have no charge because they are sharing their electrons. So it says here multi-atom particles that share electrons. So a great example of a covalent bond is the fluorine molecule that we drew, or nitrogen that's in the air that we breathe. Two nitrogen atoms will get together and share their outer electrons to become stable. Or water. Water is another example of a covalent compound. So far we've talked about two things then. We've talked about ionic bonds where electrons are transferred. We've talked about covalent bonds where electrons are shared. And I said that in ionic bonds you have a positive and a negative. That's true. And I said in a covalent bond you have no electrical charge, and that's true. But what's not true is that they're always perfect. Like right here in a nitrogen molecule, the sharing is pretty much perfect, and there is no electrical charge. And over here in sodium chloride, it's almost a perfect transfer. So there, one's positive and one's negative. But there are many, many substances in between that are kind of like not perfect sharing and not perfect transfer. We call those polar molecules. And you'll learn more about that when you are a junior. So, the last one I want to mention, I didn't put a lot about this one in the quiz, but a metallic bond. Every year there's a curious freshman or two who says, well, what about when a chunk of metal, I mean, a chunk of metal is pretty strong. What's going on there? There must be some bond going on. Well, there is. We call it a metallic bond. It's between a metal and a metal. And each atom of metal would like to lose its outer electrons, because remember, these metals are these guys on the table over here, and they're happy to lose electrons. And when they do lose electrons, that makes them a positive ion. So imagine all these positive ions. Well, you'd think, well, if they're all positive, they should fly apart because they repel. But those electrons that they lost are kind of like the glue that holds the metal together. These negatives, these electrons are flying all over the place. We say that they're delocalized, or if you were British, you'd use an S there for some weird reason. But why do I mention metallic bonds? Well, one, because sometimes kids are curious, and two, because later in this semester we're going to talk about electricity. And what do we use to send electricity through a wire? Well, we send these little electrons through a wire. And if without metallic bonding, that wouldn't happen. So I'm closing in on 9 minutes. There is a video on ionic and covalent bonding.